Thank you very much for that introduction. It's good to be known for multiple things. So, if I asked most of you in here to picture and tell me what you thought about the Great Barrier Reef, until the last talk, you probably would have said something like this. Now you probably think it looks like seagrass and mud. But we'll pretend that this is what we tend to think of when we think about the Great Barrier Reef. It's these sorts of shallow, beautiful shallow reefs, turquoise waters and coral caves. And if I asked you to picture what the biodiversity of the Great Barrier Reef looks like, it'd probably be something like this: beautiful staghorn corals and colourful little fish. But in fact, these shallow water reefs only represent about 7% of the Great Barrier Reef Marine Park. The other 93% looks pretty much like this, at least until you go under the water. Now, this other 93% is full of an incredible diversity of habitats, but also a really huge range of interesting species. Some of them are pretty familiar, so things like seagrass and these mangroves here, but others are much less familiar. So this is a deep sea coral habitat. And this is down hundreds of metres under the water. It exists in perpetual darkness and in very, very freezing cold water. It's almost the same temperature down here as it is in Antarctica. But despite the fact that this area exists in such a remote habitat, it's home to some incredibly interesting creatures. Now, I'll grant you that most of these probably aren't going to be gracing the T-shirts of the tourist stands at the Cairns Marina anytime soon, but they are some of the most fascinating creatures on the reef. Now, my particular interest in these deep habitats is an area called the mesophotic, or the twilight zone. Now, it might sound complicated, but mesophotic is a pretty simple term. Meso means middle and photic means light. And here we have a very shallow coral reef, and we can see it's bright and sunny, and this is what we typically think about as a coral reef. But the mesophotic zone, or the twilight zone, it exists in this habitat below these shallow reefs, between about 30 and 150 metres depth. And it's a very extensive habitat, and it exists in this sort of perpetual twilight. And if you look at this photo, which is taken without a flash, it might not look very interesting. But if you illuminate this mesophotic zone with artificial light, it reveals this absolutely stunning ecosystem. And not only is it stunningly beautiful, but it is also among the least explored habitats on Earth, not just on the Great Barrier Reef, but all throughout the tropical oceans. So, exploring the twilight zone for a museum worker like me is extremely exciting, but it's fraught with a few logistical challenges. So, all great explorers suffer hardships as they go exploring the world and trying to discover new things. So, for example, Abel Tasman in the 17th century had several of his crew members attacked and eaten by cannibals. Now, I'll grant you that cannibalism probably isn't a huge concern these days in most of the places we do field work, but we face a similarly tenacious adversary, which is OH&S. And so when we explored these fortunate Victorian explorers may have had to risk cannibals, but this was the attitude they took to go exploring. Whereas these days, it feels a lot more like this. All jokes aside, there's actually some logistical challenges as well with exploring the twilight zone. So those of you that are divers will know that as you go deeper in the ocean, pressure increases, and this means that for every 10 metres you go down in the ocean, you require twice as much air. And as well as breathing twice as much air, you also absorb twice as much nitrogen. So the deeper you go, you can run into really serious problems, both with trying to ensure you carry enough air, but also with things like nitrogen narcosis and potentially things like decompression sickness. The other practical challenge is if you go down to the twilight zone looking like this, it's very hard to swim around and catch small fish. Fortunately, there's some technology that helps us with these things. So this is my colleague from the University of Hawaii, Dr. Sonia Rowley, modelling what we call a closed-circuit rebreather. So it's very advanced diving technology. Basically, it allows her to rebreathe the air that she breathes out rather than breathing out bubbles. And that allows her to breathe some really interesting gases, things like differing mixes of oxygen and helium, which gives you an extremely amusing voice underwater, but allows her to dive down to depths of 150 metres or more. We can also use some fancy robots which go down and they can collect images and specimens and things like that. And if you're rich like James Cameron, you can also go grab your own submarine. And if anyone would like to donate one to me, that'd be great. You may be followed down by museum divers on rebreathers though, unless you go really deep. So while this habitat is extremely poorly known, and for someone interested in biodiversity, it's amazing that it's almost like the Victorian era. You're going down to these areas, and every single time we go, we find new species. This is just a sample of a few of the species that have been discovered in the Twilight Zone in recent years, including many of them in Queensland. So there's a huge amount of biodiversity on the Great Barrier Reef and in Queensland that we don't know about. And hopefully in the future, we'll increasingly be able to go and describe the unique biodiversity of the other 93%.